Hello viewers, welcome back to another section of my tutorial, and in this video I'm going to solve a differential equation problem which happens to be a second order linear non-homogeneous differential equation. So I'm going to use the method of variation of parameters. So kindly watch this video to the end and don't forget to subscribe. Okay, so how do we go about this? Now, first of all, to begin with this, write the homogeneous form, that is y prime prime plus y prime minus 2y is equal to 0. After writing that one down, then write the characteristic equation, which is r squared plus r minus 2 is equal to 0. Then you find the values of r1, then also r2. So what are the values of r1? After simplification, you get r1 to be equal to 1, then r2 to be equal to negative 2. So our complementary solution yc will be equal to c1 e to the power x plus c2 e to the power negative 2x. Once you get this, you are left to find the particular solution. And from variation of parameters, it says wherever you see c1, make it u1, then make here 2 u2 e to the power negative 2x. Once I get this, I'm only left to find u1 and u2. So when I find a particular solution, I add it to this to get my general solution. Stay tuned. So let's see, to find your yp, we use the Wronskian of these functions here. So if I have that, I'm going to have that to be equal to the determinant of e to the power x. I differentiate this. Then when I come here, I'll take e to the power negative 2x, and I differentiate negative 2 e to the power negative 2x, like this. And this will give me e to the power x multiplied by the expression negative 2 to the power negative 2x, then minus e to the power x multiplying e to the power negative 2x, like this. So once I get this, I'm going to get negative 2 e to the power negative x minus, this will give me e to the power negative x, and that is negative 3 e to the power negative x. So this has given me my Wronskian. Now, what do we do again? You know that whenever you find yp, you have to put it in the main equation, then also find the u1 and u2. But you'll be left with a system of equation in which we use the Cramer's rule to solve. So what do we do? We are going to get the u prime of 1, let's say u1, that is u1 prime expression, to be equal to, but first of all, let me write the general system of equation here. I'm going to get this same thing here, e to the power x, e to the power x, e to the power negative 2x, negative 2 e to the power negative 2x, and angle bracket, multiplying u prime 1, u prime 2, then the solution will give me 0 up, the down is going to give me the g of t here, x e to the power x, as this. So to find my u prime 1, like this, is the same as replacing this whole part with this and find the determinant. So 0 x to the power e to the power x, e to the power negative 2x, the negative 2 e to the power negative 2x, determinant of this, and it will give me, this time this will give me 0. I get 0 minus the expression x e to the power x, then e to the power negative 2x. This is the same as negative x e to the power negative x, like this. So this is my u prime of 1, but I'm not done. I have to divide what I've got by the Wronskian function, negative 3 e to the power negative x. And what will that give me? That will give me negative x over negative 3, also the same as x over 3, and that is u prime of 1. So once I've got u prime of 1, I can get u1 to be equal to the integral of x over 3 dx. So how do I solve integral of this? I'll put 1 over 3 outside, then this becomes multiplying s squared over 2 and is equal to s squared over 6. That is my u1. Let me go ahead and find my u2. So to find my u2, I'm going to find the determinant where this part will be replaced by this part. So e to the power x, where this part will be 0, then x e to the power x should be equal to my u prime 2. So this will give me this times this, and that will be x e to the power x minus 0 this. So this will be x e to the power 2x. When I get this, I will have to divide this by the Ross gain to get this finally. Negative 3 to the power negative x, and this will be negative x over 3 e to the power 3x by indices, and that is u prime 2. So to find u2, like integral negative x 3x on 3. Now once you have this, you are to integrate this. You have a linear function, you have exponential function, becomes by parts. So to solve this integral by part, I have a short formula here. You take negative s over 3 here, and this is the part you can differentiate to 0. Then e to the power 3x, you are going to integrate that part. So I'll write plus here. Then when I differentiate this, I'll get negative 1 over 3. I'll write minus here. When I differentiate this, I'll get 1. When I integrate this, 1 over 3 to the power 3x, like that for the second part. Then here when I differentiate, I'll get 0. When I integrate, I'll get 1 on 9 e to the power 3x. And I'll just do something like this. So my final solution will be this by this, that is positive. So negative x over 3, 1 on 3 e to the power 3x, then minus, so it will be plus 1 on 27 e to the power 3x. So negative x e to the power 3x on 9 plus e to the power 3x on 27. So we move forward where this is our u2. So our yp is simply equal to the expression here u1. So the expression here u1 e to the power x, where my u1 is simply equal to my u1. I got my u1 from here, and so it's equal to s squared over 6. So s squared over 6 multiplying the expression e to the power x, then plus my u2, which happens to be this whole expression here, negative x e to the power 3x over 9 plus e to the power 3x over 27, all multiplied by e to the power negative 2x. That is my yp. I further simplify it to be x squared e to the power x over 6 minus, when I multiply this and this, it will give me to the power x alone, e to the power x on 9, then as well as plus e to the power x on 27. To find my general solution y, I just add my c1 e to the power x, that is my complementary solution I have here, plus c2 e to the power negative 2x, plus c2 e to the power negative 2x, then finally plus my complementary solution over 6 x e to the power x on 9 e to the power x and 27. Thanks for watching this video. Kindly subscribe so that whenever I post a video you also get notified. Thanks for watching.